and handles all cyclic input. The collective lever is down at the pilot's left. The collective lever's linkage is pretty straightforward. There's a friction knob nearby to adjust the feel of the lever, so it moves more freely, or maintains its position but is a bit harder to move. We'll get into specific buttons and switches here when we look at the cockpit later. The flight stick or cyclic controls are a little more involved. Left to right movement translates through tubes and levers to the lateral control chain. Forward or back motion moves the large tube underneath, which translates through to the longitudinal control chain. Notice how pure side-to-side motion doesn't affect front-to-back parts, and vice versa. Of course, the system gives freedom to blend these axes at will. Front-to-back controls have some extra components. There's a bracket and levers linked to a cam. As the cam passes through a slot, some left-to-right input is automatically blended into the forward-to-back movement. For this particular model, designers found a tendency for side roll when transitioning to forward flight, and built a correction into the flight controls. Here's one more look at the whole control chain. Cyclic and collective commands pass from the cockpit up to the servo actuators and eventually to the swash plate and blades themselves. Heading back to the cockpit, let's switch to directional control, or in other words, the tail rotor. This is where foot pedals come into play. Again, I've included optional co-pilot controls here. There's a knob at the front to adjust pedal distance for proper pilot foot position. A couple of bell cranks pass pedal movement through the system. Co-pilot controls are hard-linked such that both pedal sets always move together. The foot pedal linkage components travel through the same tunnel as other controls, but cross inside the roof structure instead of on top. There's a servo actuator in the body midsection just before the tail boom. A long control tube travels the length of the boom,